We'll proceed in summation to integral. Okay, very difficult topic we have taken, summation to integral. Can we solve any problem by intersecting it or bifurcating it, dividing it into different sections, then calculating the solution section by section and then adding it? This is called summation. Solving a problem by summation. There is a way to solve a problem, and that is called solving a problem by summation. This is one way. There can be many ways. Solving a problem by multiplication, division, addition, solving a problem by any other means. There can be many ways. There can be many ways to solve a problem. Solving solving a problem by summation is one of the way. There can be many ways. Okay, so solving the problem through summation, and then how I can solve it. So I believe it is all right. If I'm trying to calculate, if I'm trying to calculate the circumference of a circle, then one there can be many ways. I'm not kind of guaranteeing that this is the only way and this is the best way. What is the best way to solve a problem? Okay, best way to solve a problem is whatever a person is finding easiest to him. Okay, what is best way to take an item from one location to another location? Okay, if I talk about the physical way, not using the machine, then I would say catch the item with your right hand and then lift it and go and take it to other location. That is the best way to move any item from one location to another location. Now, person who is not a right handy, he is a left handy. Okay, he does everything, but he is also applying right hand only because it is written in procedure that use your right hand, because the person who wrote it, he was kind of deft in the right hand, not in through the left hand. Okay, so probably this is not the best suited for him. So what is the best way to solve a problem? Whatever is the nearest to someone's nature, that is the best way to solve the problem. Who knows that for many people, the nearest to their heart, nearest to their habit, nearest to their nature to solve a problem is to do by dividing the problem into many parts and then solve the problem part by part, like calculating the perimeter of the circle is dividing the perimeter into different parts, n number of parts, where n can be anything. I can divide this perimeter into four different parts. This is x-axis, this is y-axis. This is circle is centered at the origin. Okay, first part is, if I talk about this is the Cartesian coordinate system. So if I say this x-axis to y-axis, this much, if person knows this much length and then he can know this much length, this much length, this much length, then he can add all four and he get the circumference of the circle. This is called summation. Now he would write summation I, summation means sigma sign I equal to 1, sigma sign I equal to 1 to 4 length or perimeter p I. The subscript is I here. Perimeter of the ith section. Summation I equal to 1 to 4. Perimeter of the ith section. Now P1 plus P2 plus P3 plus P4. This is the first parameter. This is the second parameter. This is the third parameter. This is the fourth section of the parameter. If someone add it, then he would get the net parameter. Thank you very much. Okay, now this number of 4 is increasing now. Consider summation I equal to 1 to n and perimeter of the ith section. This is a generic way of representing this kind of section of parameter where n is 4 right now. N can be 10, n can more we go in number, more we will be accurate. Because if I calculate parameter from here to here, probably person would do is from this point to this point, he will take a scale. Otherwise, curved fashion, it is very difficult to calculate the parameter. He will take a scale from here to here and he'll measure. So he will measure more or less direct line from here to here, then here to here, here to here, here to here, and he will say this is the parameter. No, 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 no. Let's divide into 20 parts. So one section, another section, like this, divide into 20 parts and calculate the length of each part. No, it will give the more accurate result. Let's make divide into n and n tends to infinity. 20 part we can add it, no problem. Okay, 100 part we can add it. But if n tends to infinity, 10,000, 100,000 division we are making of this, considering that if it is n is very high, the length of one section will be very small. If this is the one point and this is another point of this section, if I draw a straight line also and it divide into 10,000 parts, then more or less it will be perimeter of the circle without any error. But who will calculate this much? Then we need integral calculus. When n tends to infinity, then we use integral calculus. Okay, differential calculus, we know. Generally people, if someone asks, what is differential calculus? What is differential calculus? Tell me, what is differential calculus? Then someone would say differential calculus is nothing but, if someone say what is differential calculus, then differential calculus is nothing but this is x-axis. This is x-axis. Hope. I'll rephrase this. What is differential calculus? This is x-axis and this is y-axis. I'm sorry. This is x-axis, this is y-axis. Make sense? Now there is a line like this. Equation of this line is y equal to 2x. Means this is the line. Y equal to 2x is the equation of line. Okay. Per unit of x is how many unit of y? That is the question now. Per unit in x is how many unit in y? This is the question. Means if I zero, this is the zero. Zero to any length I take alpha. Zero to alpha if I take, this is alpha. At alpha, what is the height? If y equal to 2x, height is 2 alpha. Okay, if this is alpha, then what is the height? Height is 2 alpha. How much is per unit of x brings how many unit in y? 2 alpha by alpha. 2. Per unit in alpha adds 2 unit in per unit in x-axis, add 2 unit in y. Okay. Now at alpha I add one more unit here, alpha plus 1. Now tell me what will be the I. You have to add 2 here because I know y by x is 2 alpha by alpha 2. I know. Okay. Now this is but this is not differentiation. This is pure division. Y by x, that is 2 alpha by alpha equal to 2. Per unit of x is 2 unit in y. Make sense? Okay, if I say that I add 1 unit here, then I have to add 2 unit here. Make sense? Now consider instead of it is 2x or y equal to 2x, y equal to y equal to y equal to 2x. Okay, that y equal to 2x, that is true. Consider y equal to x square. This is x square and this is y. This is x and this is x square. If x is alpha, then y is alpha square. Okay, that is what it is. Now tell me, per unit of x brings how many unit in y? So that if I know that relationship, when it is alpha, if I add 1 unit here, if it is alpha, and if I add 1 unit here after the alpha, then at this alpha, it is alpha square. There how many unit I need to add? Alpha to alpha plus 1. 1 unit if I add at alpha. At alpha this is alpha square. At alpha square how many unit I need to add? Okay, that is the question. Oh, I know. Y by x, alpha square by alpha. Many times I have given this example. Y by x, that is alpha square by alpha. Alpha. Earlier it was constant 2. Now it is variable alpha. Means at any means 1 unit of alpha corresponds to alpha. 1 unit in x-axis corresponds to x unit, not constant, x unit in y-axis. Okay, this is division. Y by x means is division. Per unit in x belongs to how many units in y? Y by x. Okay, now at any alpha, at any alpha, any alpha, if I add 1 and at any alpha I have alpha square as the height. If I at any alpha, if I add 1, then at this alpha, how much I need to add so that at 1 I can, at alpha plus 1, I can estimate what would be the y. Okay, at alpha, height is alpha square. Per unit in x-axis is x in y unit. If I add 1 here, and when x is alpha, then x I have to add there. Now there it will become at alpha plus 1, the y will be alpha square plus alpha, because I have to add x, whatever the x is. X is alpha. So when x is alpha, y is alpha square. When x is alpha plus 1, I added 1. Then I have to add x there. X is alpha. Alpha square plus alpha will be new y. Wrong? Certainly wrong. Alpha plus 1 whole square is not alpha square plus alpha. Anyone can try. Alpha plus 1 whole square will be alpha square plus 1 plus 2 alpha. If I take out 1, considering 1 is very small, then alpha square plus 2 into alpha. It is 2 times than alpha, where I am saying y is alpha square plus alpha, because I know I did division and per unit of the x-axis is x unit in the y-axis. At x equal to alpha, if I add 1 unit here, I have to add alpha there. So, division is not working now. Okay, this is where we need differential calculus. Differential calculus is extension to division. Normal division, if we go, it is extension to the normal division. What I have to do now? Okay, okay, differential calculus. What differential calculus talks about? Rather than per unit in x, y by x, per unit in x is how many unit in y. Differential calculus talks in different way. Division is y by x, where differential calculus is delta y by delta x. Division is modified now. Division went to next stage now. Y by x, y by x. Now in division, y by x was meaning was per unit in x was how much per in how many unit in y. Now it is changed to per unit change in x. Per unit change in x brings how many unit change in y. These words are different. So when the nomenclature is different, when the definition is different, division is per unit of x is how many unit of y. It changed to per unit change in x is how many unit of change in y. Y by x becomes delta y by delta x, because delta x talks about per unit change. Per unit change brings how many unit of change in y, delta y. Now y by x is renamed as delta y by delta x or dy by dx. Okay, now the definition change. Per unit of x is how many unit in y become per unit change in x brings how many unit change in y. Okay, in that fashion it becomes dy by dx. What is dy by dx? If I this is a point called alpha or x, any x. If I move delta x from x, if I move delta x, then if I go on top here, this is x, then this is y. If it is delta x I moved, then this is x plus delta x, then this is y plus delta y. If y is function over x, then this is x, then this height is function over x. If this is x plus delta x, then this is function over x plus delta x. Now what I'm interested to know is, if I make delta x movement at point x, then how much movement it made in fx or y, and that differentiation I want, how much movement it made in y. At this point it is fx plus delta x. This point it is fx. Here it is x plus delta x. This is x. Now what we want is fx plus delta x minus fx by delta x. Makes sense? If I divide by how much I move along x-axis, because of that how much it moved along y-axis, then it will say per unit change, per unit change. If I how much it moved in along y-axis, if I moved delta x unit in x-axis, if I divide, the definition will become per unit change in x-axis brings how many unit change in y-axis, delta y by delta x, or delta in fx by delta x. Delta in fx is fx plus delta x minus fx by delta x. This is called first principle differentiation. This is the basic rule of differentiation. People they rename it as dy by dx or d of fx by dx, means writing in different notation. That's it. Make sense? So this is how delta x, delta y works in differential calculus. If people are ready to chop x-axis in different sections, and each section has a width of delta x, at any delta x width, how much delta y I am getting? So that is delta y by delta x at that x. Makes sense? If this is the x, if this is the x equal to 10, if x equal to 10, if I move delta x here, then how much I need to move in delta y. So at x equal to 10, every moment delta y by delta x will be different. It is per unit change in x brings per unit how many unit change in y depends upon at what x you are taking. If x equal to 1, then delta y by delta x will be different. X equal to 10, delta y by delta x. Okay, understood. At different x point, it is different, right? But can you summarize it as a function of x only, so that I can change x and I know what? Yeah, certain. That is the reason that calculus is sits upon algebra. Calculus never sits upon the numerical science. Numerical science, algebra, then calculus. Calculus works on algebra. Now I can find a generic equation of dy by dx in terms of x. Keep changing x and keep getting dy by dx at that x, and it will be different at different point. Okay, what is dy by dx for sin x? It is cos x. What is dy by dx for sin x? It is cos x. Means when angle is 0, at that time dy by dx is cos x. Cos 0 is 1. At that moment, change in 1 unit change in x brings 1 unit change in y. Means it is 45-degree rising is there. Make sense? There is a wave called sin x. There is a wave called sin x. This is sin x wave. This this is origin. This is origin, and this is the sin x wave. Now, what is the dy by dx for it? Means at any x, if I go up, this is fx or y. If I make 1 unit change here, how many unit I change in c in y? That is dy by dx delta y by delta x. Per unit change in delta in x side at point x brings how many unit change in y? What is dy by dx of sin x in term of algebra? I'm not talking about when x is pi by 2 or like that. Tell me in generic fashion. Then it is cos x. What do you mean by cos x? When x is 0, when at the beginning point, here this is the beginning point. When x is 0, at that time, if I make 1 unit of change along x axis, it will bring one unit of change along y-axis. dy by dx is cos x. Cos 0 is 1. What is 1, 1, 1? dy by dx equal to 1. Y is perpendicular and x is base. That is tan theta. Tan theta equal to 1 means theta is 45 degrees. Yes, it is 45 degrees. Means if I take a slope at this point, if this is this is a sine wave, then we have slope at different point. Okay, this is pi and this is 0. If I calculate slope at this point, that is dy by dx, means dy by dx is y by x and y by x is tan theta and tan theta is the slope. Are you talking about slope? Yes, yes, slope only. So at this point when it is pi by 2, then here slope is flat, no slope. Means dy by dx should be 0. When theta is 0, slope is like this. Means it will make 45 degree with x-axis. Okay, how dy by dx is 0 at pi by 2? Cos pi by 2 is 0. Okay, this is differentiation. When we chop into many parts and each part is delta x and then we compute delta y by delta x. Similar, the exact opposite to the first principle in differentiation, there is called repeated summation in integration. Okay, now if I want to get integration of this curve, what your curve is, this curve equation is sine x, this curve equation is sine x. Okay, this is origin. What the integration will talk, differentiation we understood. What integration will talk now? Integration will talk integration will talk if this is sine x and this is pi and this is 0 angle and this is the radian x axis, then from 0 to pi, how much area it is making, that is the integration. Rather than calculating the area, I chop this x axis into n number of parts and each section I have this area strip. I have n number of area strip now, which width as delta x because I divided it into n parts and delta x is pi by n, where here to here is pi into n chop, pi by n, delta x. For delta x, what is the height? If delta x tends to 0, I need not take both the height. At delta x beginning and delta x end, height are different. Okay, very clever people that take median height at the center of the delta x, what is the height? Multiplied by delta x, you get this strip height, strip area. Add all the strip area, summation of I equal to 1 to n, area of the ith section, where ith section width is delta xi and height height is function over x at x equal to ith section. What is your x equal to ith section? If this is 0 and this is pi, then each section has a width of 2 pi by n. So ith section, where I section number 1, 2, 3, 4, n, I to n. Ith section from here to here, ith section length, that is x, will be 2 pi by n into I. So ith section, that is 2 pi by n, 2 pi by n into I, that is the x. At that moment, what is the fx? That height into delta xi. This is the area of this strip. If I add all the strip, then I get integration of x from 0 to pi fx dx. That is same as summation of I equal to 1 to n area of the ith section. What is the area of the ith section? Function over x, where x is in the ith section. Mean x equal to pi by n into I. Delta xi, width of the delta x. If all delta x are same, there is no change in the width. Okay, it is same. I from here to here I chopped into n different parts, all are same. Delta x is same. How much it is? Then it is pi by n. Directly you can say function over x, where x belongs to the ith section, whatever the x from here to ith section, into delta xi, that is pi by n constant. Then you sum it. What is guaranteed? Consider I chop this line, this section into n part, not x-axis. This section into n part I chopped it. Okay, then I will go with different kind of independent variable, right? Independent variable is x here. If I chop in that fashion, Then if I map all the fraction on x-axis, the delta x will not be same. No guarantee that delta x will be same if I chop along this line. But whatever it is, one thing is guaranteed, that summation of I equal to 1 to n delta x, all the delta x summation will be pi only. That is guaranteed. What else guarantee is? Summation of I equal to 1 to n area of the ith section. Ith section strip, if I add all the area, ith section, it will be equal to integration 0 to pi fx dx. Okay, thank you very much. This is called calculation of the area through bifurcating into, cutting into n number of parts, the way we did in differentiation. So analogous to the first principle of the differentiation is repeated summation in integration. Repeated summation, repeated summation to integration. Repeated summation form of integration is analogous to the first. These are not written in any of the book, anyone can try. Anyway, if differentiation of this is sin x, this is sin x. What is differentiation of sin x? Cos x. If differentiation of sin x is cos x, then integration of cos x should be sin x. Okay, show me now. This is your cos x. If this is x axis and this is y axis, when this is 1, when this is 1, this where this point is hitting, it is 1. This is a cos x chart. Cos x starts from 0 at 0 radian, height is 1, and this is pi by 2. This point is pi by 2. This is cos x. Then cos x will go like this, and then it will hit back the axis at 3 pi by 2. This is minus 1 at pi. This is pi and minus 1 at pi. This is pi by 2 and it is 0. At 0 it is 1. This is differentiation. This is differentiation of sin x. Yes. Let's calculate the area. If I calculate this, if I calculate the area, if I integrate cos x, integration of cos x will give the sin x back. Differentiation of sin x is cos x. Integration of cos x means if I try to calculate the area of the cos x, integration means area. Integration of area of cos x, it will give sin x. What are you talking about? I cannot understand it. Integration of sin x means integration of cos x. If I calculate area of the cos x, it will give sin value. Area and sin. Area of cos x will give area of sin to some part. No, no, no. Area of cos x is sin x. What do you mean? I'm not able to understand. Okay, tell me what is sin value of 30? What is the value of sine when at angle is 30 degree? I believe it is 1 by 2. Sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by the square root of 2. 1 by square root of 2 will be higher than 1 by 2. Sine 60 is the square root of 3 by 2. And sine 90 is 1. Okay, now tell me what is the sinusoidal value at angle 30 degree? 1 by 2. But you said that area, integration of cos x is sin x. Means if I calculate the area, if this is cos x, where at 0 angle it is 1 and 90 degree it is pi, at pi by 2 it is 0. This is cos x. From 0 angle to 30 degree, this is 45 degree, this is 90 degree. 0 angle to 30 degree, this will hit line like this. If I calculate this section area, if I calculate this section area, this area will be sinusoidal value at, this is sine value, sine axis. At angle 30, that is the vertical line. Sine value means vertical line. This is sine theta, sine x. This is sine x, this is pi, and this is pi by 2, this is 30. At 30, if I take the vertical line, that line length is 1 by 2. But cos x, you said area, right? Both are different. One is height, and one is area. I'm talking about area only. So this is cos x. At angle 0, cos x is 1. At angle pi by 2, cos x is 0. If you calculate the area between 0 and 30 degree, 30 degree will come here. Not I'm talking about this height. If you measure the full area from here to here, addition of full area will come as the 1 by 2. I'm saying if I chop from here to here, that is pi by 6, that is a 30 degree. From 0 to pi by 6, if I chop into n part, and if I calculate the area of one part, if I add all the area, if I add all the area, the value will be 1 by 2, that is sine 30 degree. This is the relationship between integration and differentiation. Someone can try. Summation of I equal to 1 to n and then area of the ith section. Okay, summation of I equal to 1 to n function over x, that is cos x, at the x equal to ith section dx or delta x I. This will go as 0 to pi by 0 to pi by, actually I have never tried. With the fundamental only I am talking. Okay, let's try. This is a fundamental of calculus. I have never tried this in my life. Let's try it. Then it will be converted into summation integration x equal to 0 to pi by 6 cos x dx. That is, I know that integration of the cos x dx, integration of cos x dx is sin x. Okay, then it will be sin x 0 to pi by 6. It will be sin pi by 6 only. Sin 0 is 0. So it worked. Somehow it worked. Anyway, so someone can calculate the summation through repeated summation also. Okay, and then he will find one area of the ith section as a some generic form, and then he will go with the integration. Okay, anyway, in the past video we were calculating the surface area of a sphere, surface area of the sphere in pure spherical coordinate system, pure spherical coordinate. How we did that? We will do volume today. Volume in pure spherical coordinate system, the volume of a sphere in pure spherical coordinate system. What is pure spherical coordinate system? What is Cartesian coordinate system? Cartesian coordinate system is if I take any point in the vicinity, if this is x-axis, this is y-axis, this is z-axis. If I take any point in the vicinity, I can denote this point as x comma y comma z. This is the point, that is x comma y comma z. This is called Cartesian coordinate system. If I take a spherical coordinate system where one axis is theta, one axis is phi, and one axis is r, in that fashion, if I take any point in the vicinity, then that point is r comma theta comma phi. Makes sense? Okay, but there is a but. If I say that my axis is theta and phi and r, then this point is r comma theta comma phi. That is true. But if I take this point in a kind of the way we talk in Cartesian coordinate system, where everything length matter. If this is Cartesian coordinate system, this is x-axis, this is z-axis, this is y-axis. What is this point is? Point is x comma y comma z. What do you mean by x comma y comma z? From this point, if I draw a vertical, then on x-axis intersection will be x. Make sense? If I draw a vertical on z-axis, intersection will be z. If I draw a vertical on y-axis, this is on y-axis. This, I'm sorry. If this is z-axis, from here, if I go like this, it will make z. If I go like this, then it will make x. If this is y-axis, then I have to go like, okay, someone has to understand how it will hit like, from here it will hit like this. From here, actually, I said wrongly. So for x, I have to come to xy plane first, and then we come like this, it will hit x-axis. This is x. We'll come to xy plane and go, it will hit y, that is y. And then in z, I'll come to, from there I can go up, and that is a z. Similarly, if I try to denote any point in spherical coordinate system, then that point will be in length only. But if I say r theta phi, means in Cartesian coordinate plane, if I try to push the spherical coordinate, then if I say my point is in a spherical coordinate system, then all three variables should be in length only, not in angle. Two are in angle. Theta phi. Please watch our previous video and previous to previous video. Then the point is should be in length. Radius is in length, that is true. But what about theta and phi? Okay, Then we have seen that theta is r sine phi theta, and phi is r phi. This the point in a spherical coordinate. Any point in a spherical coordinate is r, comma r sine phi theta, comma r phi. This is the point in the spherical coordinate system. It cannot be r theta phi because r is length, theta is angle, and phi is angle. All have to be similar. All have to be distances, not the angle. So if I talk about spherical coordinate system, and this is the center, and this is the radius, then and this is the angle with the vertical, that is phi angle. if i say if I say what is the, if I talk about any point here, and then this is the phi angle is 0. From here it came to phi angle, it makes phi angle from the vertical, and this point belongs to phi angle from the vertical. If I talk in distance, then this is the arc distance, this is the arc distance it made. This arc distance is r phi. Okay, this is r from the center. What about theta? Okay, theta from here, if I make a cut like this, horizontal cut, it will form a circle, and this angle is theta. Okay, now this hand I have kept in xz plane. I can move like this. Now it is in yz plane. I am in between somewhere. So that from xz plane it moved theta angle. If I talk, say this, my point is r theta phi. R is all right. Phi is r phi. This is the r that it moved from its beginning position, phi equal to 0. Whereas for theta, the in xz plane theta angle is 0, but it moves like this, then it moved theta angle. In that fashion, how much it moved, that will be the arc length in the theta fashion. For that, what is the radius of this circle? Because if I chop this sphere at different point, circle will be different. If this is r, then this radius is r and this angle is phi, then r sine phi. Now, for this circle, r sine phi is the radius. R sine phi theta is the point here. Now, this point is r comma r phi comma r sine phi theta. This is the point in the spherical coordinate system. Okay, generally you won't find in the book anyway. Now, with the repeated summation, the way we are giving the fundamentals of the calculus, can we calculate the volume of a sphere through repeated summation in pure spherical coordinate system? So that is the concept that we will understand now. Okay, so I have brought my very nice sphere now. Consider this is a sphere. This is a sphere and it is centered at the origin. This is xy plane and blue color at the center is the origin. Okay. Now, if it is centered at the origin, the half of the sphere is above, half of the sphere is below. And if you go inside, and center of this sphere will coincide the blue color mark. Now, above of this, we have top hemisphere of the sphere, bottom hemisphere of the sphere. If this is point P here, what is the coordinate of point P? Okay, what is the radius here? Radius is r from the center. Okay, radius r, very nice. What is phi? If this is point P, from here, if I go exactly straight up, that angle is phi equal to 0. So phi, I moved like this and it hits point P. So that is phi. How much is the distance? That is r phi. So another one coordinate is r, another coordinate r phi. Now, if I talk about theta, then if I cut this sphere like this, everywhere I'll get a circle. Everywhere I'll get a circle. At point P, what is the circle radius? And from that radius, if this is xz plane, how much theta it moved, how much arc it made. That circle radius is r. If this is r and this angle is phi from vertical, then r sine phi is the radius. R cos phi is the vertical. Make sense? R sine phi theta. So this point P can be written as r comma r sine phi theta comma r phi. in vector form r unit vector plus r sine phi theta unit vector theta r sine phi theta theta unit vector plus r phi unit vector. This is the vector that will start from the origin and it will hit this point and it will go away. Okay, but that is r vector. That is not the r and whatever we are talking. Okay, consider like that, because if you go in another kind of coordinate system, that is r theta phi. For now, consider like that one. Anyway, now idea is how to find volume of this sphere in a spherical coordinate system. To find the volume of this sphere, I chop this sphere into n different sections. Up. If this is the radius from center and this is the radius I chop into n different parts. At any moment, radius is r, where r will go from 0 to a. A is the final radius of the sphere. At any moment, radius is r, and I chop it into n different parts. Make sense? Now, if I move like this, then I'm moving the theta angle, keeping this vertical angle phi constant. Phi is not changing. With the vertical, phi is not changing. If that is the scenario, this movement gives me one circle which has a perimeter. That perimeter I chop into n part. Makes sense? Means theta angle is chopped into n part. Now this is the phi angle, and this is the theta angle. It moves. Now keeping theta constant, I move the phi. Makes sense? Phi movement, change in phi will make another circle. There is a vertical circle. Keeping theta constant, keeping r constant. First, we moved the r. See, this is not changing. I moved r from 0 to any r. Theta is constant, phi is constant. These explanations are not there in any of the book. Now I keep phi constant and r constant, and then I move theta. Then I keep theta constant and r constant, and I move phi. Okay, movement of phi will make a vertical circle. Movement of theta will make a horizontal circle. And movement of r will make a straight line. So theta, if I make horizontal circle, that circle perimeter I chop into n part. The phi moment make a vertical circle. I chop into n part, and this radius I chop into n part. Now I have n to the power 3 number of volumes inside this sphere. Make sense? There is n number of volume inside this sphere. Chopped. Radius chopped, theta circle chopped, and phi circle chopped. This is the theta circle. This is the theta circle. This is the phi circle, and radius goes like this. Anyway, now what is the volume? Summation of I equal to 1 to n, summation of j equal to 1 to n, summation of k equal to 1 to n, where 1 to n, where we have volume of the I, j, k section, where I talks about radius, j talks about the theta, and k talks about the phi. I have made three sections, right? I equal to 1 to n, j equal to 1 to n, summation, sigma sign. Summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Volume of the I, j, k section. Okay, in that fashion, if I add all the volume, and there are n to the power 3 section we created of the volume. If I add all n to the power 3, if n is 2, only 2 part I divided, radius 2 part, theta 2 part, and phi 2 part. Then 8 volume it created, 8 I have to add it. If n tends to infinity, then I have to bring the integral calculus now. What is the volume of ith, jth, kth section? Where kth section is in phi circle, jth section is in this circle, and ith section is in radius. Okay, if I talk about the volume of the ith, jth, kth section, then what is the volume? How much is the radius? Consider radius of the kth section is delta r. I'm sorry, radius section of the ith section is delta r. I said delta r I. If this is the radius, I chopped into n part, I talk about the nth part, ith part. If this is the circle where theta is variable, and then I chopped into n part, I talking about the jth section. This is the jth section. This is the from here angle started. This is the jth section. What is the length of this jth section? What is length of the ith section in R? I say it delta r of the ith section. What is the length of this section? Okay, length of this section is r, whatever the r is. R is r sine phi. For this, r is r vertical angle sine phi. R sine phi delta theta. Well, how much delta theta of the jth section? R sine phi delta theta of the jth section. What about k? Phi angle. Phi angle, what is the radius of the circle? R, pure R. And this section is delta phi k section. Now we have summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. And then volume of the ith, jth, k is the multiplication of these three items, where these three are orthogonal to each other. Now it will become now r sine phi, I'm sorry, delta ri into r sine phi delta theta j plus into r delta phi k. If because I know all three are perpendicular to each other, this arc, that is theta arc, is perpendicular to the vertical arc, guaranteed, and all two are perpendicular to the radius, anyone can see. Now it becomes r square sine phi delta theta delta r square sine phi. Phi angle is taken at any particular phi in calculation of the radius of the theta plane circle. R square sine phi delta ri delta theta j delta phi k, where summation I equal to 1 to n, j equal to 1 to n, k equal to 1 to n. Okay, this is a fit case to convert into integration. Please watch our 3 to 4 videos prior to it. How 3 dimension we can convert into integration. We consider delta r delta phi delta theta as delta r theta phi, delta of r theta phi, and this section is function over theta r theta phi, that is r square sine phi, is we can consider an expression that is function over r theta and phi. Function over r theta phi, if I consider r theta phi as a single variable, not as a triple variable, single variable, so then it becomes, and that single variable is alpha, then it is function over alpha. Or I can just say, means I have x-axis, and this x-axis is alpha theta phi, I'm sorry, r theta phi. This axis is name is r theta phi. Then what is your vertical axis? This is function over r theta phi. In that way, we have summation I equal to 1 to n, j equal to 1 to 1, k equal to 1 to n. Means it is something like alpha equal to 1 to n to the power 3. Okay, something that is 1 to n to the power 3, whatever, it is summation 1. And then we have function over theta r theta phi into delta r theta phi. Okay, this is as good as we chopped this r theta phi axis, single axis, into n to the power 3 part. And one part has a width of delta r theta phi. Here there is a function called that we have already done. Here function called function over r theta phi. This function over r theta phi and delta phi give the area of this section. If I add all the area of this section, it gives the full integration from beginning of the r theta phi to end of the r theta phi. I can convert it now. Integration beginning of r theta phi cube to end of r theta phi cube. Okay, or sphere, whatever, 3 dimension. And then function over r theta phi d r theta phi. Since theta r phi are perpendicular to each other, it will become d theta dr d phi. It is r square sine phi. And since they are unrelated, if you see the radius is growing like this, and that is completely unrelated to theta is growing like this. It is completely unrelated to phi that is growing like this. They are all are at 90 degree to each other. So I can break the limit into three parts. R is 0 to a, theta is 0 to 2 pi, phi is 0 to pi, because phi will go from here till here. R square sine phi d theta d phi dr. If someone does this integration, he will get the volume. R square sine phi. If I integrate sine phi first, then it becomes cos phi. And then 0 to pi, it will become 2. Now, 2 I can keep outside. R square dr, that will become r to the power 3 by 3. 0 to a to the power 3 by 3. Now, it becomes 2a to the power 3 by 3. Theta 0 to 2 pi. D theta theta 2 pi. 4 pi a to the power 3 by 3 is the volume. Actually, I thought about taking this sphere volume through the spherical coordinate system in vector manner only, but it is too much time we have spent on. Okay, we'll try to do in another session. Calculating again volume through repeated summation in vector form. Okay, that we will do. One or two more sessions. Anyway, these are not available in any of the book. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.